In this question, it is given two dipole moments parallel to each other. These are the two dipoles, and dipole moments are parallel to each other, and dipoles are separated at a distance small x. Okay, and here we need to find the force of interaction between the dipoles. Okay, so let us do one thing. Let us make the diagram to the next page. This one. Here, let us consider this dipole P1 and P2 as a system, or group of the dipoles as a system, and we have one pair. One pair means we can find the potential energy of the system either calculating U12 or U21. What is the difference between U12 and U21? Let us understand. If we write U21, that means the potential energy of the dipole number 2 associated with the field of the dipole number 1, right? This is U21. If we write U12, that means the potential energy of dipole number 1 associated with the field of the dipole number 2. Both will have the equal value. So either we can calculate U21 or U12. So let us calculate the potential energy of the system. Let us calculate U21. We can write U21 equal to minus P2 dot product E21. E21 is the electric field generated by the dipole number 1 at the center of the dipole number 2. Okay, so we can observe here this dipole center. The center of the dipole number 2 is lying at the equatorial position of the dipole number 1. And we know the direction of the electric field because of dipole number 1 will be anti-parallel to dipole moment, that is P1. So electric field at the center of this dipole because of this dipole will be in the downward direction like this, and it will have the magnitude equal to 1 upon 4 pi epsilon naught P1 divided by x cube. X is the separation between the dipoles. This vector diagram, we can observe these vectors are anti-parallel. That means the angle between the vectors are 180 degree. So here we can write this equation as minus P2 multiplied by 1 upon 4 pi epsilon naught P1 divided by x cube and cos 180 degree. Okay, cos 180 degree equal to minus 1. So minus 1 and minus will be positive. So this value will become U. Let us write instead of U21 U, because U12 and U21 both will have the same value. So here we write potential energy as 1 upon 4 pi epsilon naught P1 P2 divided by x cube. Okay, so here we got the potential energy of the system. We can calculate the potential energy, this value, by simply calculating U12 also. So we got the potential energy. Here one thing is to be noted, potential energy of the system is positive, and potential energy of the system, if it is positive, that means dipole will repel each other. So there will be force of repulsion between the dipoles. Now come to the calculation of the force value. We know the dipoles are parallel to each other, okay, and separation is x between the centers of the dipole. That means the force between the dipoles, and also you can observe this potential energy function is related with the x coordinate, that separation between the dipoles. That means the force between the dipoles can be calculated by taking partial derivative of u with respect to x. So we can write F equal to minus del u by del x I cap. So this is the force between the dipole. Here we can observe this 1 upon 4 pi epsilon naught P1 P2 both are the constant term, this and this. So there is the derivative of 1 upon x cube. So let us write this term 1 upon 4 pi epsilon naught P1 P2 outside the derivative like this. So we need to find the derivative value of x to the power minus 3. X to the power minus 3 derivative should be equal to minus 3 multiplication x to the power minus 3 minus 1. Now we can solve here. Minus minus will be positive. So this value will be equal to 3 P1 P2 divided by 4 pi epsilon naught x to the power 4 I cap. We can observe here the force is in the positive x direction. That means dipoles are repelling each other. Dear aspirants, Cengage India has launched the new edition of our JEE Advanced Physics books. Please visit www.cengage.co.in to buy a copy. You can also buy the books from Amazon or Flipkart.